Irrational numbers, properties and operations. In this module, you will learn the following. Introduction to irrational numbers. Non-terminating and non-repeating decimals. Representation of irrational numbers on number line. Finding irrational numbers between two rational numbers. Finding irrational numbers between two irrational numbers. Comparison of irrational numbers. To understand what are irrational numbers, we first need to know what are rational numbers. A rational number is any number that can be expressed in the form of a by b, where a and b are two integers and b is not equal to 0. For example, 2.5 is rational because it can be written as the ratio 5/2. Take a look at the screen for more examples. An irrational number is a number that cannot be expressed in the form a by b. For example, square root of 2 is irrational as its value goes on like 1.4142135 and so on. The value of square root of 2 is non-repeating and non-terminating. Let's see what non-terminating and non-repeating decimals mean. Whenever you have a ratio of integers, the corresponding decimal value either terminates or repeats in no more digits than the size of the denominator. For example, 3/7 repeats in 7 or less digits. 1/25 repeats or terminates in less than 25 digits. Thus, if a decimal never repeats and never terminates, it cannot be represented as a ratio of two integers. So we call such number irrational and not a ratio. An example of this is the number pi. The decimal equivalent of pi never repeats and never terminates. Let's now see how we can plot irrational numbers like √2, √3, etc. on the number line. You know, we can also plot these irrational numbers on number line. Let's first make a triangle with measure of 2 of its sides as 1. By using Pythagoras' theorem, the hypotenuse will be square root of 2. Let's now place this triangle on the number line. As you can see, if we plot the length of OC on the number line, we get a measure of √2 on the number line. Further, we just need to join OD and plot its length on the number line again. This gives us length of √3. Similarly, we can plot √5, √7, etc. on the number line. In this diagram, all angles are right angles. Can you tell which out of OB, OC, OD or OE is rational? Let's see how we can solve this. The lengths can be found using the Pythagoras theorem in the right-angled triangles. See the calculation on the screen. Therefore, OC is equal to 5, which is rational. There exist irrational numbers between two numbers. You can find these irrational numbers. Let us see how. If the given two numbers are distinct positive rational numbers such that the product of these two numbers is not a perfect square, then square root of this product is the required irrational number. If you need another irrational number between these numbers, then you can take the product of this new irrational number with one of the original numbers and take its square root. This will give the required second irrational number. Similar to previous example, you can also find irrational numbers between two given irrational numbers. Let us see how. Find square of the given irrational numbers. Choose a number between these squares. This number should not be a perfect square. Take the root of this number. Therefore, this is the required irrational number. You can also compare two irrational numbers. If A and B are irrational numbers of the same order, say n, then, therefore, as 12 is greater than 5, therefore. Now let's see what we can do if the order of the irrational numbers is different. If order of given irrational numbers is different, we need to take LCM of the orders. Now, since, therefore, summary, a rational number is any number that can be expressed in the form of A by B, where A and B are two integers and B is not equal to 0. An irrational number is a number that cannot be expressed in the form A by B. Pi is an example of an irrational number. If a decimal never repeats and never terminates, it cannot be represented as a ratio of two integers. So we call such number irrational and not a ratio. There exist irrational numbers between two numbers. You can find these by using simple calculations. You can also compare irrational numbers by making their orders same.